And welcome to Naughty Notes. And again, we're in the pandemic version. The year is 2020, and we're doing alternative assignments because we're working from home. We're following the iSchool model here, which is a little different than our textbook. So I'm going to give you some help with quiz number 0803, and it corresponds to chapter 12 in our textbook. So let's get to it. We've got 5 problems here, and the first one, oh yum, starts with a snow cone. Well, yeah, think of an ice cream cone. And we've got this gumball pushed down to the bottom. So let's look at a solid model of that first. You see what's happening is, well, see I've got this cone, and this green area is the area that's going to be edible. I think I'm going pistachio myself, and let me see if I can make a solid of revolution here to make this look more exciting. If we take this and we spin it around, we revolve that solid, and that's what we got. And you can see, whoops, oh, whoa, 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 whoa. If I look at this, cannot extrude. I'm not trying to extrude. Okay, sorry, I'm trying to orbit. Yeah, I've got this cone with this bit chopped out of the bottom. I've got a cone cut off the bottom and a hemisphere. You can see that little hemisphere right there. So let's get to it. I'm going to take this away, and I'm going, like a good engineer, we're going to put up a model. In this case, an auxiliary diagram. We know that the cone is a solid of revolution. We're spinning around here. There's a bunch of different numbers you can get, but in my hypothetical example, I've got 1.5 inches here. And I said that the gumball has a 1/2 inch in diameter. That means it's a 1/4 inch in radius. Okay, now here's the big assumption. I don't like this, but I guess it's not that significant for us. But I dropped that gumball in there, and it's going to come to rest there on the tangent. See, the tangent's there. It's going to be tangent, and that point of tangency is over here somewhere. I know for the purpose of this exercise, the authors were probably thinking you're going to assume this, which, is easier, and we're going to go with that. I don't like it, but you can see there's going to be a little bit of error, and that is, it can't be tangent at that point, but this will give us similar triangles, and it'll make the exercise way easy. So we're going to make an assumption that it squishes down there a little bit more than it really does. So let's get to it. I've got the volume of the cone. That's the big cone. Use a capital C, and minus the wee cone, and then the hemisphere. So I'm going to subtract all that stuff. And, I know the formula, pi r squared h. And in this case, I might use, sometimes I'll use capital R, capital H for the bigger one. And, and that's it. So let's see if we can do something else here. I'm going to factor out the pi. So I'm going to factor out the pi because you're just going to put pi in at the very end. So why keep multiplying by it a bunch of times? And then I'm going to make this big assumption. Similar triangles right there. And we know that that's not quite right, but we're going to go with that. And then I can fill in all this stuff. Yikes. Now, I don't want you just copying down numbers because you just got to get the method. Remember, you're squaring 1.5. Now, you know your table, so 15 is 225, so that would be 2.25. 0.25, well, that'll be 0.0625. Remember that. Well, anyways, I'll just crank through some of the arithmetic, and let's see what it comes up with. I'll let you do all this, but you're going to come up with about that. Now, you see these 3's very nicely divide out here in this particular example, so that works out pretty well. And well, let me see. So if I do this, And you'll have to trust me on that, but I'll let you go through that. These are very small numbers. You see, so it's not very significant here. So that looks like it's going to give us about 2.23, 2.23, and then I'll multiply that times pi, and there you go. This one is supposed to be a multiple choice, and that's going to be a cubic unit, so cubic inches. Nice ice cream, or nice slushy. All right, well that's enough on that one. I'm pretty much think, yeah, this is going to be a multiple choice because they didn't tell you how to calculate with pi. I used the pi key and worked out pretty good. Hey, let's go to number 2. Oh, the old silo problems. I love the silo. You know, well, we drew it in SketchUp. I don't know that we need to bring this out, but there's a couple things I want to point out on the silo. You'll always get these problems and you'll be given a diameter. Remember, the diameter for the cylinder is the same as or radius in this case. Radius of the cylinder is the same as the radius of the sphere, hemisphere that is. But watch out for heights, because in this hypothetical example, if I told you the silo was 40, you would have to know to subtract the 10 to make the cylinder 30. If I said the cylinder was 30, you have to add, you got to keep track of what are you being told in your particular example. Over here, actually I don't remember what they told you, but in any event, keep track. The height, remember, the height of the entire silo includes the radius of what I have colored blue here. So, let's get crack-a-lackin' here. The total volume is going to be the volume of the cylinder plus half the volume of a sphere. We can put our formulas in there. We know that a sphere is 4/3 pi r cubed. So half of that is 2/3 pi r cubed. And we are going to use the same pi. We've got the same r. So this is going to be easy squeezy. So I'm going to factor and substitute there. I went off the page a little bit. And so I'm going to factor out the pi. And let's just go through these numbers really quick. Your numbers might be a little different. And I'm looking at this saying, all right, that's 100 times that's 100 times 30. That's going to be 9,000. And, 3,000. Wait, hang on a second. 100 times 30. Yeah, that's 3,000. And this is going to be 2,000 thirds. 10 cubed. Remember, 10 cubed is 1,000. 10 times 10 times 10. That is 1,000. 10 to the third power. So 2/3 of that, that'll be 2,000 over 3. You could have gone decimal there, but watch, I didn't because I was doing this. You can go any way you really want, but we were told to use 22/7. So I just find it easier to work with fractions because now you got a bunch of numbers. And if you want to go decimal here, because I know you do, well, take all the numbers and then just multiply them and divide them. So remember, times 22 divided by 21, or if you want to be divide by 7, divide by 3. And there you go. And round it to the nearest whole number. So in this case, we're going to have 11,524 in our hypothetical example. So, and again, you could have turned this into a decimal down here. You could have done it differently, but we went like that. So, all right, that's the method. So make sure you get this one right. And that's a good one, classic. The silo always comes back to get you. All right, we got 3 more, but they're kind of short. Oh, yes. Now this one, you've got this thing that looks like an inverted pencil. And now let's see what we got here. And we're going to fill this thing up with sand. So you're filling, I guess we don't really need the 3D model. We'll just put that away, and we'll put that one away. We are told that this sand drips at a rate of 10 pi cubic millimeters per second. That's an odd way to express it, but until somebody was keeping it ready for a math class. So this is the text, and yours will be different. So yeah, let's just get to the math. We're going to fill it with sand. So its volume is going to be the volume of the cylinder plus the volume of the cone. We know that the formula pi r squared h for the cylinder, and in this case 1/3 pi same r squared, different h for the cone. Now I want to point out in this one, I actually did some arithmetic for you. You were given the total height, you were given 18, and you were given 54 for the entire height. Oh yeah, it's over there. See the 54. So you had to know to subtract and make that 36. That was the key, or one of the several keys. One of the places where you might slip up if you're not careful. Now I'm going to factor out pi r squared, because pi r squared is, well, it's constant in this problem. And I'm just going to take the h1, the first height, 36, and 1/3 of h2. So watch how easy that works out. And let's see. So I'm going to, I don't even know what I did. Hang on a second. Oh, doggone it. Hang on. I messed up. Start again. Okay. Back up. Sorry about that, everybody. So pi r squared, the h1 is 30, the first height is 36. Now 1/3 of the h2, well, 1/3 of 18 is 6. I can just add those two together, 36 and 6. Now that's what I meant to do. See, I was trying to be clever. Then I'm supposed to hide all these and bring that up there. Okay, so I write over the space. And now we can say, I can multiply that together and then say, well, we could multiply by pi, but stop. Look at that. The sand drips at a rate of 10 pi cubic millimeters per second. And, if you're not sure, should you divide or multiply? You're going to divide. But here's your good friend, dimensional analysis that comes in. If you write it this way, it's pretty clear that you're going to be dividing. Because watch this, in dimensional analysis, the units divide out. In this case, the pi's are going to divide out. And it looks like you've got about 270 seconds on this calculation. And that's it. Oh, all right, we're almost done. 2 more. All right, similar solids. The similar solids goes like this. Similar solids theorem tells us that, let's say I got these 2 segments. This is one-dimensional. And I'm going to say that this represents 2. This is 2, doesn't matter, 2 feet, miles, kilometers, any linear measurement. Well, when I go to 2 dimensions, I can best see this when I'm using the figure of a square. You could even count them. You got 4 there. 1, 2, 3, 4, 5, 6, 7. You got 25 there. So the ratio of the areas, when we go from 1D to 2D, the ratio of the areas is the square of the ratio of the corresponding sides. We actually learned that a while back. But when we project into 3D, just like you'd expect, you can see it right there. The volume, if you were counting up all the little cubes that are built inside there, this one, I can count. There's 4 in the front, there's 4 in the back, there's 8 total. That's 2 to the 3rd power. 2 times 2 times 2. But this one, 5 times 5 times 5. Wow. That's 125 cubes inside this one. So that is the ratio of the volumes in this case. So that's pretty cool. And so you got the lengths, 2 to 25. Areas, 2 to 5, 4 to 25, 8 to 125. Now you know how to solve the last one. This is a similar solids problem. Now, you didn't have to draw it, but I drew it for you because you were told a couple things about these pyramids. They're both going to be square pyramids, right? So that means their bases are squares. And you can see you've got a 12 by 12, you've got a 24 by 24. Okay, now check out their heights. In their heights, you've got a 16 by, again, twice as tall. So the one on the right is twice the size in every linear dimension. The square is, the footprint is, 24 by 24. The height is twice the height of the smaller pyramid. And that brings us up nicely to, well, how do we do this? The similar solids theorem says, well, if a side of A is to a side of B, so I think I apologize, I wrote that backwards. It should be B to A, but I think you get the idea. So it's going to be 1 to 2. Because B is the bigger one, okay? And that means that this is, therefore, the volume of A to B is going to be 1 to 8 because it is the cube of the ratio of the corresponding sides. So if you had to say how many times bigger was it? 8 times bigger. Pretty impressive, huh? Okay, last one, and I think we're going to, oh my God, I don't think we're even going to answer this one. Look at this. If the volume for a 3D pyramid is 400, well, what other kind of pyramid is there? Of course it's three-dimensional. All right, so you got these two solids, and if the volume of this one is 400 and the volume of this one is 800, and that is in a cubic measurement, how many times bigger? Nice, don't waste your time. It's twice as big. I mean, in this case, you're given volume. 400 to 800, you're doubling. So the volume is times 2. Corresponding sides are not, but the volume is double. And that's it. I hope you did all right on this quiz, and or you took good notes, because you can't have a browser open during these quizzes. So go ahead and get them all right this time. And thank you for watching Naughty Note.